I'm Pat Wilkinson, been building for the last 45 years I think it is, in the local area. 15-20 years ago we looked at the climate situation that was happening in the world and we realised that we were building the wrong way. Things had to change. So we've been building since then energy efficient buildings, new houses for clients to live in where they don't use lots of energy just to keep warm. The building behind me is two houses, one above the other, which we're building in Bishop Stortford. It'll be the most energy efficient house in Bishop Stortford due to the way we build. For all it's brick clad on the outside, that belies the timber frame which lies behind it. This is a basic stud work that we're working with, our I-beams which make up the wall. These are a foot thick, 300mm, which we'll completely fill with insulation. The insulation will be cellulose fibre, warm cell 500. On the front of this we will screw sheets of plasterboard which will contain that insulation. This is the cellulose fibre we use. This is recycled newspapers which have been chewed up and minced up in a machine. It's been treated with boron salts and something to kill stop the rodents, rats getting into it and mice. This is completely fireproof. You can't make it burn, so it's completely safe and is one of the best insulation materials there are, as well as being a recycled material, which makes it even better. There's no oil in the production of this, as there would be with rock wool and other materials. This is blown in to the walls through holes cut through the plasterboard. We put a hose in which goes right down to the bottom of the panel. We start the machine, we blow the material in until it's completely solid right up to the top, and that is then insulated. This is the airtight layer that we use. It's a German product called Intello, which is a vapour permeable membrane which stops the vapour transferring through the wall into the wall and to outside. We stick this to the side of the window frame before we fit it with tape so that we can create a completely airtight fit around the window. This is then pulled tight around the edge and taped again to the airtight layer which we put across the whole wall. In the corners we have two strips so that they overlap one over the other, so that when they're cut into the corners there are no gaps which can let air through. All these joints will be taped and completely covered so that there's no risk of any air infiltration. Here we have the airtight layer, again the Intello, which is taped and jointed and completely airtight. We put these battens on just to create a space for putting the cables in so that the cables can come down, and then we'll put a plasterboard box on the wall for the cables to come out of, with a socket on the face of that. We also run pipes in this space as well if we need to, but as we haven't got a full heating system we don't need many pipes. We only need to supply the kitchen sink, the bathroom and the toilet. In this house we haven't got a standard heating system at all. We have no radiators anywhere. We have no underfloor heating because it's not necessary. Our house is so energy efficient that people living in it produce enough heat to keep it warm. If the house is left unoccupied for a while it can cool down because it's the people in the house which are keeping it warm with the computers, and every person gives off 100 watts all the time. So if the house is left empty for 2 or 3 weeks it will cool down. In those circumstances we need some sort of heat input. So in the ventilation system we have a small radiator, a 2 kilowatt radiator, which if needed is activated so that we warm up the air which is pushed into the bedrooms, and the whole house is then slowly warmed up over the period of 2 hours or so. This then brings the temperature up to a normal living temperature of say 18-20 degrees. On the roof here we have solar panels which cover half of the front south side of the roof. This should produce enough hot water for 60% of the hot water usage in the house for domestic hot water. These solar panels are augmented with the help of a wood pellet boiler to produce all the domestic hot water that's required for washing and bathing and washing up and everything else that's needed in the house. So 60% of our energy is from the sun, and the remainder comes from a carbon neutral source of wood pellets, so we're not producing any CO2. As far as the water usage in the house is concerned, we've installed, or will be installing, a rainwater harvesting system, so that any rain that falls on the roof is collected and run into a tank after being filtered. It is then pumped when required to the house for all uses except for drinking purposes. It will be filtered so that there's no particles in it, and also be treated ultravioletly so that there's no bugs or any risk of any health risks. The air quality in these houses is far better than a normal house because it's controlled. The airflow is continuously changing, whereas in a normal house, which has trickle ventilation in the windows and the drafty doors and everything else, this air movement is completely uncontrolled, making it cold, damp and miserable a lot of the time, and the air can get very saturated with water, causing condensation. Whereas with the mechanical ventilation system, we don't have this problem. The air is fresh all the year round. These are the German windows we use. These have two methods of opening. We can either open them side hung like that, and this one opens also side hung, so we've got plenty of fresh air in the summer. These windows are aluminium clad on the outside, so that we never have to do any maintenance to them at all, ever. These windows are triple glazed and argon filled, and also have a coating on them to reduce energy loss through the glass. They're one of the most efficient windows made in the world today. There's another way of opening them. We can just put them in ventilation mode so that they open just at the top, and they are a ventilation in the summer with security, so that you can't get any thieves in. Building in this way is not that much more expensive, probably 5%, perhaps 8%, because we don't fit a heating system. This money, which would have been used for the heating, is put into the other aspects of the house, as the insulation and the air tightness and the heat recovery. So the costs are not increased too drastically. But the energy usage over the lifetime of the building is way, way down from what most houses are. And this is the way all houses should be being built now. It should be the law that we build in this way. Every house should have to have solar panels on, not have to fight its way through planning control so that we're allowed to put them on. This has to be a requirement of building regs. Insulation levels, as we have them here, have to be a requirement of the building regs. The air tightness has to be tightened so we're down to the levels that we're getting here. In this way we might have some impact on the climate in the future. In the future, this is the way we all have to build. In the future, this is the way we all have to build.